Okay, so in this one I want to look at a problem where you have to find the derivative of a function using the formal definition. So we have to go through that whole process of finding the limit as h approaches 0 using the definition. So I'm going to write the definition here. Limit, so it's the limit as h goes to 0 of the function as you increase a little bit and then subtract the function at the value x and then divide by h. And if you don't remember where this formula comes from in the first place, I'm going to quickly draw it here. Let's say you have this graph and I'm going to do an arbitrary graph and I just want to find the slope here, right? So what I do, this is x equals h and this is f of x, right? If I increase it by a little bit, let's say this distance from here, these two lines are h, and so this point is f of x plus h, right? What I want to do is make h get smaller and smaller, right? So bring this value here closer and closer to x, and then find the slope between the 2 points. So it would be, the slope is the rise over run, so it's the slope which is f of x plus h minus f of x all divided by x plus h minus x. And then the x's cancel out, and then we want h to approach 0. So that's where the definition comes from. So I'll keep it here if you want to look at it some more. This is x plus h. So now we have to plug it in plug in this function into the definition. So limit as h approaches 0 of, and this is where we see that we have to do a lot of work. Alright, this is the f of x plus h. Now we have to subtract by f of x. It would be minus this, right? All divided by h. So now we should go about expanding this whole thing out. The way I'll do it is just by using this one. If you just know the binomial theorem, it's just x cubed plus 3xh plus 3xh squared plus h cubed, right? So I'm going to move this over here quickly just to give me some more space right here. So this is away from this. And then I want to do this. This is 2x squared plus 2xh plus h squared, right? And then I'll shift it over a little bit to the right. And then subtract, I'm just going to expand the minus, or distribute the minus sign out. And then this is kind of the side work that we need to show. We need to show that we have to expand the cubed term and the squared term and everything else. So I'm just going to continue this line. This is like side work, not really a part of this yet. So I'm just going to keep simplifying this further and see what we can get. So right, that's the same thing. I just I distributed the minus 2, and we see stuff cancels out right here. We have this cancels out with this, right? What else? Let's see, can we combine anything? We can, is there any x squared? This cancels out with this. Any x squared h terms? There doesn't seem like it. So we can continue with our problem. So it's the limit as h approaches 0 of this 3x squared h plus 3xh squared 4xh minus 2h squared all over h. If you notice, one thing that's very interesting I find is that every term has an h, so we can get rid of this h. This goes to 1, this goes to 2, this goes away, and this goes to 1. So I'm going to scroll down here just a little bit. There we go. So now this is equal to the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 4x minus 2h, right? That's the limit. Can we plug in h now? Yeah, we can. We can just straight plug it in because it's a polynomial kind of with this, so it's continuous always. This function is, so it's 3x squared, this goes away, and this goes away, right? Because they all have h, and anything times 0 is 0. So this is what the derivative is. So here, let me zoom out and see the whole problem at once. There we go. Oop, did not mean to do that. Let's try to go down. There we go. So just a quick summary. We wanted to find the derivative using the formal definition here. This is the definition right here, right? I'm going to highlight it because this is something you should remember. This right here, you can scribble it in. This is super important. What we did, I showed you how to get it. If you don't know how to get it, this is a picture you should also kind of keep in the back of your head. And then we have this, I plugged it in, I had to expand the numerator right here, and I simplified through. I found that this was the, let me write it in. This was the simplified expression, and then I just plugged it into the next step. I got rid of all the h's because every h shared a common factor, and this is usually when you know you are doing something correct, when a lot of stuff just starts canceling out, especially with a polynomial like 3x cubed minus 2x squared. And then we see that a lot of things evaluate to 0 when you plug in the limit, and then this. And then if you actually know how to do it using the power rule, you can always use the power rule as like a double check method. So remember, you just bring the power down and you subtract 1. And let's see, let me just do it quickly here. Let's see, so the derivative of f of x is 3x squared minus 4x, right? And then let's see if this is true, right? If we know this, and then how to find the derivative, you just bring the power down and subtract 1, right? Bring the power down and subtract 1. This is 3x, and then you subtract 1. Minus 2 times 2, that's 4, and then x to the first, which is this x. So it is correct using a double check method that you want.